This is a key on the worksheet on power and polynomial functions. And so the direction says for each function indicates whether the function is a power function, a polynomial function, both, or neither. All right, so let's look at number one. So number one, we have, and you can't see it very well here, so I'm going to go ahead and write it out here. So number one, you have this function, 3 times x to the negative 8th power. So remember, a power function has this form. So a power function has this form. It has a form f of x equals some real number times x to a power, and then this power can be any real number. Okay, so any real number. It could be negative, positive, decimals, whatever. Any real number, but it can only be one term. Okay, and it's got to be x. All right, so it's got to look just like that. So when you look at number one, it looks like this. A is 3. You have your variable x as your base, and then your power, your exponent is a negative 8, which is a real number. Okay? So remember, though, your base must be x, nothing else. So number one is a power function. All right, now, is it a polynomial, though? All right, so remember, a polynomial function has this definition. So a polynomial function. All right, first of all, let's talk about the terms. All right, so each term in a polynomial function has to have this form. A times x to the n power, all right? And I could have used n here, but I use p, so let's just use n here. So a times x to the n power, but n must be a positive integer or 0. Okay, so n must be a positive integer or 0, or you could say a whole number. All right, so n must be a positive integer or 0, and you could have a bunch of those. So in other words, you'll see something like this sometimes. It'll be written as a sub n x to the n plus a sub n minus 1 x to the n minus 1, and then plus a2 x squared. I'm running out of room here. Apologize for that. Plus a1 x to the first, and then plus a sub 0. So each of those terms must satisfy this. A could be any real number, and your exponent must be a positive integer or 0. Okay, so a could be any real number, and then n must be a positive integer or 0. So if you look at this right here, this is not a polynomial for the fact that my exponent is negative. All right, so that's why it's not a polynomial. So all I can say is that this is a power function only. All right, now number 2 confuses some students sometimes because we know this. We know, and I'm going to go ahead and write that out here. We know that if you have, let's say, the square root of 7. We know that I can write the square root of 7 as a rational exponent, so it'll be 7 to the 1/2. Okay? And so when I have something like this right here, I know that the square root of 3x minus 2, I can write as 3x minus 2 to the 1/2 power, right? And so we know that in a power function, the exponent can be any real number. Well, 1/2 is a real number. But the problem is this. Your base has to be x only. So notice your base is 3x minus 2. So your base is not just x. Your base is 3x minus 2. So that is not a power function. That is not a power function. So, and it's not a polynomial for the same reason. Well, first of all, you notice that this is not an integer. 1/2 is not an integer. All right, so we're going to say neither here. Okay, so this is neither a power function nor a polynomial. Now, number 3, I have h of x equals 5x to the 9th. Now, that one's easy, right? That's easy. You know right away it satisfies this condition right here for a power function. You have your real number a for a. Your base is just x, and your exponent is a real number. All right, so that's a power function. Now, is it a polynomial? So remember, polynomial has one or more terms. It doesn't always have to have a bunch of terms. It can be just one term. And notice that a is a real number. Your exponent is a positive integer. It's a whole number in it. And so therefore this is both a power function and a polynomial. So the answer there is both. Okay, so that's both. All right, let's look at number 4. So number 4, we have, let me go ahead and move this out the way. All right, so number 4, we have k of x is equal to 2/3 x to the 7th minus 8x to the 9th plus 3x squared. So notice that first of all, this is not a power function, right? Because you have more than one term to begin with. So this is not a power function. Power function, you only have one term. Is it a polynomial, though? So you have a bunch of terms. Is it a polynomial? Well, if you look at the coefficients of your terms, they're all real numbers. But in particular, look at the exponents. That's what it's going to tell you right away. So notice this exponent is a positive integer, this exponent is a positive integer, and this exponent is a positive integer. So this is a polynomial. All right, so that's a polynomial. All right, number 5, you have f of x is equal to 5 times x to the 7th power plus 3 times x to the negative 5th plus 7x minus 2. So right away you can tell that this exponent is negative. So it cannot be a polynomial, right? Because in a polynomial function, all those exponents are positive integers or 0. This is negative, so it cannot be a polynomial. And it cannot be a power function because you have, first of all, you have more than one term, right? So this is neither. Okay, number 6. Number 6, we have f of x equal, 7x, let me rewrite it, 7x plus 5. So notice that you have two terms, so it cannot be a power function. So is it a polynomial? And the answer is yes. So your exponent here is 1, and then your constant 5. You have a constant 5. Now, remember I said the exponent is positive integer 0, right? So notice, see this expression right here? I can write it like this: 7x to the first plus 5 times x to the 0. So that's where you see that 0 at. So x to the 0 is 1. 1 times 5 is 5. All right, so a constant term always has this equivalent expression. 5 can be written as 5x to the 0 because x to the 0 is 1. 1 times 5 is 5. All right, so this would be a polynomial. So it's a polynomial function. Number 7, you have g of x is equal to 3 to the x. All right, so remember in a power function and also in a polynomial function, your base is x, right? So notice that my base is a number, it's not x. In fact, my exponent is x. So this is neither. Now you're going to learn in another section that when you have a base here that is positive, real number, and your exponent contains a variable, that this is a exponential function. So that would be an exponential function. We're going to put that here. So that's an exponential function. Exponential function. All right, so that's another section. So that's an exponential function. Okay, so then let's look at number 8. Number 8, you have f of x is equal to 6 divided by x plus 2. All right, now, so be a little bit careful with this, because some students, even though this is a rational function, so that's a rational function, compared to, let's say, this one, number 9, which is g of x equals 9 over x squared. That's also a rational function, but there's a difference between those two. In number 9, I know from a previous course that I can rewrite 9 divided by x squared as 9 times x to the negative second power, right? And so notice that this is a power function. This is a power function because my exponent is a real number. So this rational expression is also a power function. But here, that's not a power function. And the reason is because you don't just have x in the denominator, you have x plus 2. So I just want you to think about what I'm about to do here. So 6 divided by x plus 2. Do you remember how I had 9 divided by x squared, and what I did was I took that x squared that was in the denominator and I put in the numerator? Well, whenever you do that, whenever you go from numerator to denominator, denominator to numerator, the sign of the exponent changes. So here, if you think about this, I can write this as 6 divided by x plus 2 to the first, right? Those are the same. And if I take this denominator and write it in the numerator, I get 6 times x plus 2 to the negative 1. All right. The problem, remember, that this is not a power function because here my base is not just x, it's x plus 2. All right? Okay, so this one right here would be neither. All right, number 10, the last one. Okay, so let's do number 10. So number 10, I have f of x equals 7x squared minus 5x plus 2. All right, and so notice that each of those terms, obviously it's not a power function, right? Okay, because you have more than one term, but each of those terms, the exponent is a positive integer or 0. So you have, and let me go ahead and write it out here. So I just want you to see this. So you have 7x squared to the, 7x squared minus 5x to the first plus 2x to the 0. So notice that each of my terms, the exponent is a positive integer or 0. So this is a polynomial function. So that's a polynomial function. All right, and so that is the key to this worksheet. All right, so that's the key to the worksheet on power and polynomial functions.